8.3, Proving Triangle Similarity by SSS Similarity and SAS Similarity. So along with angle-angle similarity, there's two other methods to help us prove that triangles are similar. These are shortcuts, again, where we don't have to go through the dilation transformation. The first one is side-side-side similarity. If you can show that all corresponding sides are proportional, in other words, each ratio is equal to each other, then we can say the triangles are similar. And when they're similar, again, everything that happens about similarity happens. So we're going to get congruent angles as well. Here are three triangles, and we'd like to decide whether this triangle is similar to ABC or whether this triangle is similar to ABC. So they're in color so that we can compare short sides with short sides, long side with long sides. So I'm going to compare first, I'm going to compare these two right here. And I'm going to compare the short side with the short side, which means the reds. So triangle ABC short side to triangle DEF short side, and that reduces to 43. And now I'm going to compare the long to the long. So that'll be 16, which is the long to the long over there, 12. And that's going to be 4 to 3. So far that looks pretty good. The ratios are still the same. The medium, which is the green, and that'll be 12. And then I'm going to compare it to the medium, which is 9. And again, that's 4 to 3. So these look like the two that are going to be similar. But let's go ahead and check out the first. I'm going to do this in a different color. The first one and the last one. So I'm going to compare short with short. So that'll be 8, which is the red, over to 8. And that's going to be 1 when I reduce it. Long to long will be 16. And the other long one will be 16. So that's 1. So far that looks pretty good. Now I'm going to compare the medium, and the medium is 12 for this first triangle, and the medium over here in this triangle is 10, and here's where it fails. This is going to be 6/5. All the ratios have to be the same. So these two are not going to be similar, only these two right here. And that's how you find out, by comparing shorts with shorts, long side with long side, medium side to medium side. Okay, let's go ahead and find the value of x that'll make these triangles similar. In other words, we want all sides to be proportional. So I'm going to write out the extended proportion, AB over DE equals BC all over EF, which is equal to AC all over DF. AB is 4, DE is 12, BC is x minus 1, and EF is 18. Now what I'm going to do is, before I cross multiply, I'm going to reduce. So this is going to be 1/3, which means in order to get to 16, I've got to multiply the denominator by 6, so which means I've got to multiply the numerator by 6. So I know that 6, because these two 18s equal to each other, 6 is equal to x minus 1. And so x is equal to 7. Now if this doesn't make you feel comfortable, you can do it this way. And you can actually cross multiply. And 4 times 18 is 72. And then we're going to have to take 12 times the quantity x minus 1. 72 is equal to 12x minus 12. So 12x is equal to 84. And if you divide both sides by 12, you're going to get 7. So there's different ways to do your algebra to get to your x value. And that's what we needed. Okay, your turn. See if you can find the triangles that are similar. Write the similarity statement. And see if you can find the length of the other side lengths of a triangle that are similar to triangle RST. Stop the screencast and try it. Okay, here are the answers. What I tried to do is I first tried to compare these two with long to long, and then I compared these two long side to long side, and then I compared these two long side to long side, and I got 2 to 3 and 11 to 12. Now I took these two triangles and I compared the short with a short, and that's 5 to 6 when I reduce. Then I compared medium to medium, and that's 2/3. And so what I'm seeing is, I'm seeing the long to long, I'm sorry, and the short to short, I said medium, the short to short, I see them coming up the same. So what I'd like to do is, what I'm talking about is this triangle compared with this triangle. And I'm going to compare the mediums now. And the medium will be, medium is 24 over, and the medium over here is going to be 36. And 12 goes into here 2 times, and 12 goes into here 3 times. So all of these have a 2 to 3 ratio. So it's these two triangles that are similar to each other. Now let's see if we can't put the letters in the right order. Now L is the side between the short and the long. So I look for the angle that's between the short and the long. Here's the short and here's the long. And so L and Y have to go together. Now M is between the short and the medium, short and medium, so I have to go over here with short and medium, and it goes with Z. Once I get 2 letters in place, the third letter has to go in place. To do the number 2, I have triangle RST, and I know it's all its lengths. It's short, it's medium, and it's long length. We are trying to find the sides of another triangle where all we know about this other triangle is the short side. So I put 12 underneath the short side of triangle RST. And this is a 2 to 1 ratio. So I know this has to be 2 to 1. So I know the medium length will be 15. And this is a 2 to 1 ratio. So this is 33 halves again. So I've been able to find all 3 sides of another triangle. All right, the next method is called side angle side similarity. And it's when you know this side's and this side's ratio, so you have a ratio between them, and the ratio between these two sides also have the same ratio, and that's called proportional, and the angle between them are congruent, that's this, then you can say the triangles are similar. All right, here is an opportunity for you to decide whether the triangles are similar. Stop the screencast and then let it go once you're done. And here's the answer. What I've done is I've compared the, I'm trying to see if SR and PN have the same ratio as RT and PQ. So I've done this. I put a question mark to see if they're the same, and sure enough they are the same. They have an angle between them that's congruent, so the answer is yes by side angle side similarity. Now in this case I set up the correspondence, the proportional correspondence or similarity. No, it's not called that. Just the proportion here for the sides. I substitute all the numbers and I reduce, and they all have the same ratio. So the answer is yes by side, side, side similarity. And that's the end of the screencast.